Here's the mandatory experiment on the conditions for equilibrium. So we have a diagram straight away. You'll see we have 2 Newton meters, or 2 Newton balances, and they're going to measure the force upwards. So the meter stick is being pulled upwards by the 2 balances, and they will give you the force upwards. We then have 3 weights, so there are 3 forces downwards. We also have the weight of the meter stick, which is not in the diagram at the moment. Remember that the conditions for equilibrium are that the vector sum of all the forces are equal to 0, and the sum of all the moments about all fulcrums is equal to 0. So we need to show both. And here's what we do. So you'd find the weight of the center of gravity, find the weight of the meter stick and the center of gravity of the meter stick. The weight is very straightforward. You'd place the meter stick on a mass balance, get the mass, and then multiply that by 9.8 to get the weight. To find the center of gravity, you can hang the meter stick from a string and adjust where the meter stick is hanging until it's in equilibrium, which will mean that it's horizontal and it's not rotating clockwise or anti-clockwise, or it's not rotating in any way. And when it's not rotating anymore, you've found the position of the center of gravity. Those 2 things will need to be obtained before setting up the experiment. Then you set up the experiment as shown in the diagram. What you want to do is measure the forces on the Newton balances, read the weights from the masses, and then read and note the position of each of those forces acting on the meter stick in the diagram. Okay, then your calculations, you'd have to calculate the forces up and the forces down. So add the 2 Newton meter forces together, add the 3 weights, and add the weight of the meter stick together, and the forces up should be equal to the force down. You then need to calculate the clockwise and the anti-clockwise moments. If you want to pick whichever turning point you choose, that's fine, unless it's specified in the question and they tell you to pick a particular point. Obviously, if they tell you where to pick a point, you have to use that point. So there are a few values there. We have the weights, we have the distances, and we have whether they're clockwise or anti-clockwise. Okay, so what I'm going to get you to do is pause the video, and then will you work out the forces up and the forces down, verify they're equal, and the clockwise equal the anti-clockwise moments, and verify they're equal as well. Okay, last bit. There are the calculations done. Make sure you've got those. You've got a conclusion, which is restating the 2 laws of equilibrium to verify that you could do it. And then we have precautions. They'll all have to be included in your mandatory write-up.